So who's right? I see a lot of people look at this and think, well, I can just add the 50 and the 50 and get 100, but that's not true. So let's think about why. Let's think about the square root of 4 plus the square root of 4. Well, the square root of 4, I know, is 2. So we have 2 plus 2, this should give us 4, right? Now, using this method of adding what's inside, I would say that this is equal to the square root of 8, because 4 plus 4 is 8. However, the square root of 8 is not 4, right? We know that the square root of 16 is 4. And so this is not equal to this, and therefore this is a wrong way of doing this. So I cannot say this equals square root of 8. And so in the same way, the square root of 50 plus the square root of 50 is not equal to the square root of 100, okay? So how do we do this then? The way you want to approach this is by trying to think of 50 as a product of two numbers and have one of those numbers be a perfect square. A perfect square is a number that you can take the square root of and get a whole number. So 50 is really 25 times 2. And 25 is a perfect square because we know the square root of 25 is 5. And so the square root of 50 is equal to the square root of 25 times 2. Whenever you have the square root of a product, this is actually equal to the product of square roots. And so now the square root of 25 is actually 5, so we have 5 square root of 2. And similarly, the square root of 50 we already know is also 5 square root of 2. So this original problem is nothing more than 5 square root of 2 plus 5 square root of 2, which is of course equal to 10 square root of 2. Okay, and this is equal to square root of 200 because 200 equals 100 times 2, and so the square root of 200 is equal to the square root of 100 times 2, which again is the square root of 100 times the square root of 2, and the square root of 100 is 10, and the square root of 2 is square root of 2. So this is the right answer. Were you right?